All right, this is Managerial Economics ECP 3703. Tonight is February the 19th, 2013. We are having our last class preparatory to the midterm exam, which is a week from tonight on the 26th at 6 o'clock, not 5:30, in this room. You will need adequate writing materials and paper and a calculator. Other than that, I will prepare a reference sheet of equations, and I put these on the board. Those are the ones I'm going to start with, and I'm going to rely on the class tonight and anybody that wants to post anything to the discussion forum if you have some suggestions on other stuff you would like to see on the reference sheet.
Is slope on there?
Who?
Oh, God.
Slope?
Slope.
Okay. No. I will put the stuff about the slope. Yeah. Just leave it at that. Slope. Add stuff on the slope and the intercepts. Cool. Anything else? Anything going on in your lives? Anything of particular import? Concern? Questions?
Let's just get through this.
Let's just get through this. Well, I brought with me problem sets 1 through 5. And so I figure if you've got some questions on any of those you want to look at, we will. And then we want to chat a little bit in terms of costs, marginal costs and marginal benefits. There were a couple of multiple choice questions in one of the problem sets that required a little bit of that. We want to look at that. Let me make sure I'm not telling a lie here.
Come on now, you can tell a lie. Really.
Well, I try not to tell too many of them too often, because then I forget what I said. Guess not. Do you have particular issues on any of the problem sets you want to look at?
I have a question on problem set 4, question number 5.
Okay. Just a minute. Keep the marks here.
I mean, it's so simple that I'm just being stupid.
Sometimes they're simple, and sometimes they're not. Problem set 4.
Yeah, question number 5.
Okay, this is the multiple choice question. It says if price increases from $5 to $7, so in that sense, price 1 is $5, price 2 is $7. We see that the quantity demanded in the first instance goes from 150, and it falls, as it should with a higher price, to 100. They want us to calculate the value of the own price elasticity of demand. And again, relying on my notation, that's the percentage change in the quantity demanded divided by the percentage change in the price. And so, the quantity demanded change is 50, and its average is 125. The price change is 2, and the average price is 6. Okay, so far? I'm going to do it kind of old school. 50 over 125 times 6 over 2 or 3 over 1, whatever makes you happy. 6 times 50 is 300. 2 times 125 is 250. So I've got equivalently 30 over 25 or 6 over 5. Which means I get 1.20.
That's what I got.
And it is a negative number because the price elasticity of demand is always negative. And I think the answer key gave you an answer of 1.24 or 1.25, and that's just nonsense.
Okay, so I'm not getting stupid.
If this is the correct answer on the test, the other 3 answers will read 0.67, 9.4, and 103. Okay, so you know you're close.
So the
If you
correct
got,
answer is.
if you got 1.24, 1.25, or 1.3, you know it ain't none of these,
Yeah,
Okay.
okay?
that was when I asked you for class, because
Exactly.
I got 1.21 on my calculator.
Yeah, I was like, wait a minute, it's not even one of the answers.
When I do it this way, it's exactly, you know, there's no rounding in there. But when you plug in decimal numbers, the
Yeah.
calculator's carrying them on out ad infinitum.
Do you want our calculators to be set at a certain decimal? Like, you know how like it's 0,
I thought you
1,
said
0,
three.
1, 2,
I know.
3?
No, I like at 4 decimals, but if you want to work at 2, as long as you show me each step of the way along what you're doing,
Okay.
no problem. Good. What does that mean, by the way? Price elasticity of demand is 1.20. What does that mean?
Oh, negative 1.20?
Well, it is a negative, but what does a 1.20 elasticity mean? What's the first thing? Is it elastic or inelastic?
It's elastic.
It's a lot.
It's elastic, because it's greater than 1 in absolute value. So we know it's elastic. So, what will happen if this firm decides to raise price? What will happen to their total revenue?
It'll go down.
Yeah.
It'll go down. And in fact, you could use the numbers you had and calculate them. You had 5 at 150, and then you had 7 at 100, right?
Yeah.
And so you went 5 times 150 was 750, but when you raised the price, your total revenue, in fact, fell. And that's that relationship, and maybe this would be a helpful diagram for me to put on the reference sheet, that when we are talking about price elasticity of demand, E sub D, we want to remember that on a straight line demand curve, the bottom half as opposed to the top half, what's the difference?
Top is elastic.
The top is the elastic range, the bottom is the inelastic range.
And you don't want to operate in the bottom.
Exactly. You do not want your prices set in that range, because every time you raise price, you make more money and you sell less stuff or do less work. So, having that picture in your head, you know, price and total revenue move in opposite directions up here, price and total revenue move in the same direction down here, then you're on track. Cool. Make a note. Draw that picture for reference. And I may, in fact, ask you to be drawing some graphs on the exam. What would you have said if this were your company and you calculated that coefficient to be 0.97?
I'm doing something wrong. I would say I'm doing something wrong.
How? How do you know, or what are you doing?
0.90?
0.97.
So it's
You're underpriced?
0.97. You're operating in an inelastic price range. What's the word for that? Stupid.
Yeah.
You're underpricing
You're
your product,
underpricing.
or you're underpricing your services. Yeah.
You're right, stupid.
It's economics terms, kind of technical, but you know, it gets the point across. All right, what else? Other questions? Oh yeah, these are pretty straightforward.
So doing this, because what I'm doing is just doing the problem sets over and over again.
Yeah, as long as you understand what you're doing.
Yeah,
Not
I mean-
just remembering numbers or...
Because even if I plug different numbers in, so if I stick with the problem sets and some in the book, I should be okay.
Yeah, I think so. When I get ready to make up the exam, the first thing I'm going to do is go to the problem sets, and I'm going to extract parts from there. And I may try to twist them or tweak them a little bit.
Be evil?
Absolutely. Particularly if I'm in the middle of a martini. Or the third one.
Then it gets a little...
I'm open to anything you want to talk about here. In the meantime, I made a couple of notes out of the textbook. I want to be sure I had these formulas in there, but I think we've covered them all now. Yeah.
Last night I did the ECP self-test questions.
Yeah, that's got some of those squirrely questions on it.
Yeah, because
That's the part I didn't print out.
I know, it threw me off because I was like, oh, multiple choice, these look easy. And then like the key in the back, some of them would say easy, and I'm like, oh my god, I can't even get the easy questions. But, like, because I never made it to calculus, so I didn't understand derivative.
That's the one thing I want to do tonight. Because
Okay.
the simple part of it we're going to use is really pretty quick and simple. May I borrow your questions for a minute?
I marked all over that bad boy.
You need to be exposed to this. They give you cost and revenue functions or demand functions, or they call them marginal benefit functions and such. Let's see if we can find one. It's got stuff to a certain power. Real simple. If they tell you the cost function is 6 times y squared, you could build a table from that said, here's y and here's the cost. If y is 1, the cost is 6, right? What happens if y goes to 2? 2 squared is 4, 4 times 6, 24, right? What if y went to 3?
9, 50.
3 squared is 9 times 6,
54.
54?
No!
Yeah.
Yeah.
Good.
Don't
And
second
one
guess
more.
yourself.
If you produce 4 units of y, what happens to your total cost?
16 times 6 is 72.
16 times 6, 96?
90. Oh. Yeah.
That's okay. So, do you see what the equation is telling you, right? It's telling you how much your total cost changes when you produce more y. It's a cost function. And in this case, it's, pretty straightforward. But what happens is that when we start talking more about this, and we'll do this on the next exam, we want to know what the marginal cost of production is. And the marginal cost is the cost of producing one more unit. Think of this as a hypothetical. I'm making buckets of paint. And I look at this next bucket of paint that I'm getting ready to put together, and it's going to cost me $12 in terms of materials and overhead, and also implied in that in economics is a profit, a return. And I say it's going to cost me $12. If the market price for this paint outside is $11, do I want to produce this thing? No, it's going to cost me more than I'm going to make, so I'm not going to produce it. I want to know how much extra revenue will it make, the marginal revenue, given its extra marginal cost. And what I want to do to maximize my profit is I want to keep producing and selling paint until the marginal cost rises up to the marginal revenue. And so my rule, and I'll write it shorthand, profit maximization. Pi means profit. Profit maximization occurs when you produce such that marginal revenue equals marginal cost. That's what we're always after. As I produce more, typically, my marginal revenues fall and my marginal costs rise, and I'm trying to find the point where they intersect, where they're equal. We'll go through that in a little bit more depth in a minute, but how do I find the marginal cost from this cost function? And I can do that. I'm going to tell you what it is. It's 12y. What did I do to get to 12y? I took the coefficient, whether the power, the exponent times the coefficient, and then I reduced the exponent by one number. Y to the 1 is y. See what I'm saying? What if the cost function had been 6y cubed? What would my marginal cost be? 18
Y squared?
y squared. Yeah. Okay? That's all it is. So what happens if you have a constant up here? Cost is 120 plus 6y to the 4th plus 2y cubed. There's my cost function. How would I find the marginal cost, or in calculus, the first derivative of that? Terms without a y in it are going to drop out. So this won't even appear. My cost is going to be 4 times 6 is 24 y cubed plus
6y squared.
6y squared. That's it.
So, all right, you just said that a little bit fast. So what
Okay.
you would do is you would take the y3 times 2.
3 to 2 is 6,
6.
and reduce the 3 by one number.
Okay. So do you do that in every one to get the margin?
Every term that's got a y in it.
Okay.
Okay? Let's do this one. The cost is 120 plus 4y plus 2y to the 6th.
Well,
The 120 drops out because it doesn't have a y term. This is to the first power.
So that's gonna be.
1 times 4 is 4.
4
Plus
plus 12y to the 5th.
12y. Okay?
Okay.
And
So
then,
now, how would you write that? How would you write that as an explanation so that when I get home, I'll remember what the heck I did?
you'll watch it on video and you'll see how many times we did it in different ways. You basically take the exponent times the coefficient and reduce the exponent by one number. Let's do a couple more. There's your total cost function. 61 plus 4y plus 13y squared plus 9y to the third.
26.
If it doesn't have a y term, it drops out.
So like 4.
This is y to the first.
27y to the second.
So 1 times 4 is 4, and this becomes y to the 0. What is y to the 0?
Well, that's
1. Any power to the 0, 1. So you're left with 4 plus
26y.
26 y to the what?
First power.
First power, so we don't have to write it.
And then
Plus?
27y to the second power.
Good. 27 y to the second.
And that's marginal cost.
That's the marginal cost.
Oh, that's simple.
Yeah.
So much simpler than what is in the book. It's like,
Now, will an equation like that always have y's?
It depends on if that's the product. The product could be an X or an R or whatever else, but yeah.
Well, I understand that, but they wouldn't be mixed as in a demand function.
No, at least not at what we're doing. And honestly, if I give you any of this, it'll be nothing more difficult than that. It won't be very complicated.
oh, that's cool.
This is not a math course. I don't care what you keep saying. It really isn't.
Okay, so for the next question in this, and I haven't done these yet, the marginal benefit,
This is where?
it's number 2 on that same set.
Okay. So same thing. Where they say the marginal benefit, you could say that that is the marginal revenue in the sales function. It's the same idea. 400y minus y squared, 2y squared, sorry. That's the total benefit equation. What's the marginal benefit?
400 minus
400.
4y.
4y. Okay?
So it's still the same equation, but the terms cost and benefit are just interchangeable.
The thing, yeah. It's, you know, if you were a business, benefit means revenue. So you're comparing your money coming in revenues to your money going out costs. Same idea. Look at number 3 there.
So that just rolls back to MC equal to MR.
Yeah.
Okay.
Look at number 3. We have total benefits, 100y minus 8y squared. Total costs of 10y squared. What level of y should we be either producing or consuming, depending on our point of view? What's the appropriate quantity of y? We want to set the marginal benefit equal to the marginal cost.
So 100 minus 21.
Oh,
And
I
then
see.
you solve
So
for
I got
y.
marginal cost,
20y.
I got marginal benefit, I set them equal. 20y equals 100 minus 16y. Moving that over, I'm going to get 36y is 100. And y is going to be, I don't know, 2 and 28 36.
Well, they just give us the fraction, they don't even ask us
7, 9,
to figure it out.
277 or something like that. Well, they
Yeah,
give
I have 2.778.
2.778, okay. Which is answer whichever here.
D.
D, 100 over 36, exactly, right? Divide by 36. You don't even have to do the division. Once again, if you see this at all on the exam, it'll be nothing more than what you just seen right here.
Thank you, Lord.
It was just like really crazy when I was looking at it last night. I'm like,
Now, say again?
I said it was really crazy looking at it.
Oh, sure it is.
I was like, I brought it to my boyfriend who was like really mathy. I'm like, I go, this is economics, but look at this. He's like, oh, that's the derivative. I'm like, explain to me.
Yeah, right. Oh, that's the derivative, smacker.
Yeah.
At least your boyfriend knew what it was. My husband thought it was Egyptian.
I think that's classic.
I would have felt like it.
Because he just saw me just doing all this stuff. And he goes, what is this?
I was wondering before.
Did you notice any other particular questions in this self-test that were intriguing?
Because if that's the case, then, you know, that's simple now.
This is. And what do we know? Most of life is simple once you know what's going on.
We just did the
Unfortunately, we don't
complicated-
usually arrive there until the moment before our death. So,
I like number 11.
number 11,
Yeah, it just said, or the answer was like none of the above. And I was like, oh, cool. I just wanted some clarification.
okay, hang on. Let's write it out up here. We've got the quantity demanded of X is 10 minus 2px plus py plus m. The price of the good X is $1. The price of good Y is $10, and income is 100. And they say, given these prices and income, how much of good X will be purchased? This is just plugging these numbers back in like we do with the big long equation. And so we get what? 10 minus 2 plus 10 plus 100, 110, 120, 118. And in fact, none of those answers was on there. Cool.